Hello friends, I am here for shoot my next video, that is sixth video, and I'm not still find how to frame this video topic wise, because the thing is that my aim is to explain you the Maxwell equation from uh, and in the process want to form an entire foundational uh, course on the physics. So the next thing, I'm just figuring that what I should teach in the next video before going to the mechanics, the principle of mechanics. In a principle of mechanics, we study in Newton's law and etc. But before that, what are the worthful thing that we can discuss? So it would help us in the our next explanation or etc. We can refer them. So the next thing I think would be the told you. Uh, I think is a some discussion on a cross product and dot product in vectors. Why I am thinking about that, because uh, as this course is intended to foundational physics, which would be helpful to senior secondary classes. So as from my perspective, from my side, the class 11 student required a good explanation of scalar and vector. What are scalar and what are vector in physics? So because till 10th any calculation or uh, any kind of mathematical work that these kids do till 10th would be scalar in nature. So it's a thing that you don't need to learn scalar. You already know how to add them, how to multiply them, how to divide them, anything, everything, I should say, everything that you learn till 10th, any calculation is a scalar. So scalar is just at a definition level, what is scalar is, and everything about the scalar would be so clear to you. The another thing is a vector. Vector is a different kind of uh, things which you encounter in physical world or in mathematics. Its application in physics is very much everywhere. So you need to understand what are vectors, what how we represent them, and how vectors add up, how scalar multiply with vector, and how scalar add to vector, everything else you have to know. These calculation how to handle vectors with scalar or vector with vector, or yes. So what is the difference in vector? In a very short, I would tell you, then I would explain this on a proper way. Vector, in a vector, the multiplication has two types. In a scalar, if you multiply 2 with 3 or 3 with 2, you would get 6, and both the multiplication are equivalent. But in vector, if you have a two vector, suppose a vector A and vector B, and you multiply these vector, so you have two options to multiply. You can multiply so that the multiple you would get has no direction, means scalar. Another kind of multiplication in vector is a cross multiplication or cross product. When you multiply two vector and the multiplier or the multiple has a direction, then this multiplication is called cross product. How to do cross product and how to do scalar product, it's a subject of learning, but basically it is that. And addition also, in scalar 1 plus 2 is a 3, but in vector a plus vector b is not always some constant number. It depends the angle between vector A and vector B. To how to cater this angle in is a worth learning process, worth learning topic. How to find basically the resultant of two vector when we add or subtract two vectors. So this is the main thing. What is vector and what is scalar? This is just an introduction. I would tell you in a proper way. I think this would be the good topic for Maxwell equation 6. What I would name them, I name them a discussion over scalar and vector. This would be the nice topic for this video. If you find this video slow, I try this. You can watch this video more than 1x. 1.5x is fine. Hurry 2x is also good if you can bear with it. And this is enough. So explain this concept on a board. So here I wrote everything I need to explain in the first part of this scalar vector explanation. So this is our Maxwell equation 06. So this is the 06, and what we are studying, scalar and vectors. Much about vector, less about scalar. So basic things about vector are scalar are those quantity which does not have direction. Or you say, when we talk about scalar, we don't have to tell the direction of these quantity. For example, 1 liter of water doesn't give you it has anything related to direction. But if I told you about weight, something is weight about 10 newtons, it means that 10 newton force which has direction in downward. Whenever you lift something, you would feel the weight, direction of weight in downward direction. So weight has direction. So there are multiple quantities. What are the quantities? Quantities, anything which can be measured, are called quantities. On the basis of direction, we classify this quantity as a scalar or vector quantity. So let me complete this scalar part first. So what is a scalar quantity? A scalar quantity is just a quantity which just has a magnitude or some scale, no direction. So how do we represent these quantities? Any symbol, x, y, a, b, capital, small, not anything unusual or you don't know. Most of the things you already know. The operation, mathematical operation related to scalar quantity, addition, subtraction, multiplication, division, is same as you learned till 10th class. And now comes to vector quantity. Enough for scalar. It comes when we study vector, how do vectors add with scalar, then it's come again. But for now, this enough. Let's come to vector quantity. The quantity which has a direction is called vector. Simple. But what is a vector and how it is a different? I'll give you a small explanation. Suppose this is a plane, xy plane, conventional xy plane. If I say A, which is a scalar quantity, has magnitude 2 in direction of x. For the direction of x, we use a symbol I cap. So it means that 1, 2, here A lies at position 2. Or another vector B is 2i, comma 3j. J is the spatial symbol we denote the direction in y direction. So what it means, 2 from x and 1, 2, 3 from y. Here is the point B. So in a scalar quantity, you have these kind of things, and you can represent as. But in a vector quantity, for a vector quantity, suppose a vector A, vectors are represented by a spatial symbol, this kind, capital letter, usually capital letter, but we also use sometimes smaller letter. So main thing is the arrow on their heads. This tells you that it is not a scalar quantity, it has direction, it's a vector quantity. So if I have similarly 2i cap as a vector, it does not mean this point 2 just as. It means the arrow drawn from this origin till A. Similarly, vector B. And the component along x-axis and y-axis are given as an additional notation. So obviously these things cannot be added because of a principle of homogeneity. If you don't know principle of homogeneity, it means the only quantity which has similar nature, same nature, can be added to each other. So it is along x-axis, it's along y-axis, so it cannot be added. So if it is cannot be added, this we can represent this. So what it means the same point, but not the same point only. It means an arrow drawn from O to B. So vector quantity does not mean the point on a coordinate plane. It means an arrow, and but scalar is just a point on a coordinate plane. So it does not know, we can't know how you reach at point 2 from any other point. But in a I cap as a vector quantity, the point you reach point A from this O through this line. So direction is given as we draw these point as arrow. So imagine them vector as a arrow. This is, I'm not just give you an analogy about this arrow, not just because it's an explanation that vector is arrow. You can feel these quantities. Suppose velocity is a vector quantity. So experience whenever you are moving that something pulling you like a force. So you feel the direction, and similarly in acceleration, whenever acceleration apply, you pull in this direction. You can feel something like a rope pulling you. So this arrow thing is not just an analogy, it's a representation what we feel when we encounter with vectors. So the next thing what I can say is how to add or how to multiply these vector, what are different kind of vector. But these things you can learn in any other normal school classes. So if there is any need, I would do that in a different video, not with Maxwell equation. Obviously I will tell you what is mean by cross product and dot product, but in a different section, or when a physics makes demand, only then, not just because I have to cover multiplication or division. When it demands, which is not very far, so we will discuss the cross and dot product. So that's I think enough for this video in the explanation of what is a scalar quantity and what is a vector quantity. These are the main point which should come in your mind whenever you learn about scalar and vector quantity. So let's close this video here.